Hey students, in this video we're going to cover section 7.7, which is about volume of rectangular prisms. And today our learning target is I can find the volumes and missing dimensions of rectangular prisms. So first let's talk about how do you even find the volume of a rectangular prism? It is the product, remember product means multiply, of the area of the base and the height of the prism. So we multiply together the area of the base and the height of the prism. And to get the area of the base, we're doing length times width. So another way to think about it is that you're multiplying the three values, length, width, and height, all together. Length times width times height. This is how I personally like to think about it. Volume equals length times width times height. Well, let's actually write the word multiply so we remember that that's what's happening here. L times W times H. Now, when we find volume, we have to make sure that we always label our answer with units. Label with units. And just like how area, we had a special kind of units, units squared, for volume, we actually need to label with units cubed. Here's why. Because we're multiplying together three different dimensions, length, width, and height, I'm multiplying together the units three times. Units times units times units. We learned that when you have repeated multiplication, you can rewrite this as a power. Units to the third power, units cubed. So because volume is three things multiplied together, three different dimensions, three different units, we label it with units cubed. So we're going to jump right into the first two examples here, part A, part B. We're going to find the volume of each prism. So what I like to do is first, I like to label the length, width, and height so I know the three values that I'm going to be using. Length, width, and height, L, W, and H. And really, it doesn't matter too much which you label length, width, and height, because in multiplication, the commutative property says that the order doesn't matter. Whichever order we put these in to multiply them, we'll get the same answer. So volume equals length, 7/8, times width, 1/2, times height, 5/8. Length times width times height. Now, we haven't really multiplied together three fractions before, but just like when we had two fractions, we still do want to look for cross canceling. And the way I do that is I compare all of the fractions together. So first, I'm going to look at the first two, here and here, and see if there's any cross canceling. Nothing fits into 7 and 2 to make them smaller. Nothing fits into 1 and 8 to make them smaller. Now I look at the second set, 1/2 and 5/8. Nothing fits into 1 and 8 to make them smaller. Nothing fits into 5 and 2 to make them smaller. And finally, I still want to look at the outside ones, see if there's any cross canceling between these two, the beginning and end. Nothing fits into 7 and 8 to make them smaller. Nothing fits into 5 and 8 to make them smaller. So there is no cross canceling to be found. That means we can multiply straight across to get our answer. 7 times 1 is 7 times 5 is 35. 8 times 2 is 16 times 8 is 128. And you can use your calculator for those individual pieces for multiplying across the top and across the bottom. So we get 35 over 128. Again, we have to label it with our units, in this case meters, and remember it's volume, so it is cubed. 35 over 128 meters cubed. Okay, next we're going to do part B. Again, we need to label the length, width, and height. Length, width, and height. And I'm going to multiply them together, length times width times height. So volume is length, 3 over 2, times width, 3 over 2, times height, 3 over 2. And again, I'm going to look for cross canceling. So 3 and 2, nothing, 3 and 2, nothing. Second set, 3 and 2, nothing, 3 and 2, nothing. And then I compare the outside ones. 3 and 2, nothing, 3 and 2, nothing. There is no cross canceling to be found, so I can multiply straight across the top and straight across the bottom. 3 times 3 is 9, times 3 is 27. 2 times 2 is 4, times 2 is 8. And now on this one, there is one additional step. Because we ended up with an improper fraction, the numerator is greater than the denominator, we do want to make it a mixed number. So first, how many 8s fit into 27? Well, that would be 3 of them. 8, 16, 24. I can get 3 of them. That only gets me to 24, though. I want to be at 27, so I still have 3 pieces, or 3/8 left over. 3 and 3/8. And then do not forget to label it with your units, in this case inches, cubed. Volume is cubed. So that's how we find volume of a rectangular prism, length times width times height, label it in units cubed. Another way to remember to label this in units cubed is that volume is the space inside something. right? It's how much stuff we could fit on the inside of each of these, how much we could fill them with. So think about filling these with little cubes. How many cubes fit inside? That's why we label it in units cubed. Next, we're moving to example 2. Write and solve an equation to find the height of the computer tower. So here's our computer tower. It looks like we know the length and we know the width. We do not know the height. That's what we're trying to find. And we actually know the volume. So what I'm going to do is I'm going to first write down my volume formula. Volume equals length times width times height, LWH. And I'm going to replace each piece of this, each of these variables, with their values. The only one I don't know is h. So h will stay in h, but I can replace volume, length, and width with their values. So volume is 1,792. So volume equals length 7 times width 16 times height. I do not know height, so I'm going to leave it as h. So this is my equation. When it said to write an equation, we have now done that. The volume, 1,792, equals the length, 7, times the width, 16, times h, the height, the unknown height. And now we're going to solve the equation. I'm going to figure out what h needs to be. Well, there's actually two numbers being multiplied by h first, and it might seem kind of backwards, but I'm actually going to multiply them together first. That way there's just one number over here that I have to undo. So 7 times 16, that makes 112. So I can rewrite this as 112h, 112 times h. This side stays the same because I didn't do anything to it. All I did was multiply 7 and 16 to make this side a little bit shorter, a little bit simpler. Now I can go ahead and work on getting h by itself. How do I undo times 112? Well, I divide by 112, and whatever I do to one side, I must do to the other side. In our calculator, 1,792 divided by 112 is 16, and on this side, times 112 divided by 12 undo each other, leaving only h left over. So it looks like 16 equals our height, or our height equals 16 inches. Notice that I'm not saying inches cubed because I didn't find volume on this one. I found a missing dimension. I found height. Height is just a measurement of distance, so it's just inches, not inches squared or cubed, just inches. All right, on our final question, our final example here, it says the dump truck described below, here's our description, its length, width, and height, delivers dirt for $2 per cubic foot, or foot cubed. We could say it either way. How much does a full load of dirt cost? So what this is asking is if we find the volume, the amount of dirt that fits in this dump truck, how much is it going to cost us to deliver that amount of dirt if it's $2 per cubic foot per foot cubed? So first I need to find the volume of the dump truck. I need to figure out how much dirt is going to fit in it. So the volume is the length times the width times the height. So my length is 17, and I'm going to write that as 17 over 1 actually, because I'd like it to have a numerator and a denominator. Times width is 8. I'm going to write that as 8 over 1 because, again, I'd like it to have a numerator and a denominator. And finally, my height, 4 3/4. This needs to be rewritten as an improper fraction, so I'm actually going to do that over here first, and then I'll write my new height over here. So to make a mixed number an improper fraction, we use the MAD method. I multiply my whole number, 4, times my denominator, 4. 4 times 4 is 16. Then I add that to my numerator. 16 plus 3 is 19. And my denominator stays the same. It will stay as 4. So 4 3/4 I've rewritten as 19/4. So here we go. Length times width times height. Now I'm going to go ahead and look for cross canceling. So I'm looking at the first two fractions. Nothing works for 17 and 1. Same for 8 and 1. Now I'm going to look at the second two fractions. Nothing works for 19 and 1. But hang on. With 8 and 4, 4 would fit into both of those. 4 fits into 8 2 times. 4 fits into itself once. So there was one set of cross-canceling there. And then lastly, let's look at the first and last fraction. Nothing for 17 and 1, nothing for 19 and 1. So I'm ready to multiply straight across. If I take my calculator and do 17 times 2 times 19, I end up with 646. And if I do 1 times 1 times 1, I get 1. 646 over 1 is really just 646. Again, don't forget to label it with your units, feet cubed. So this is the volume of the dump truck. This is how many cubic feet of dirt will fit in the dump truck. And so then the question said, how much is it going to cost if every cubic foot is $2? If it costs us $2 per cubic foot. That means I need to take the cubic feet, 646, and multiply it by the $2 per cubic foot. That gives me 1,292. This means that it's going to cost me $1,292 to deliver this amount of dirt.